3D concrete printing system is an emerging technology that enables making concrete structures by adding successive layers of concrete to form a three-dimensional object. Let's take a closer look at a 3D concrete printing system. Various types of mixers could be used for preparing the printing materials, ranging from full-size batching plants to drum mixers, intensive mixers, or even desktop mixers for small batches. I should note that the cement-based printing materials usually consist of fine aggregates and a high amount of binders that results in a mix with a high yield stress and viscosity. So a high shear rate mixers like this IRIC intensive mixer is a good choice for printing materials. Drum mixer may not give us enough shear for preparing the printing materials. After mixing, concrete should be transported to the printer. Pumping concrete is suitable for large-scale prints. In small scale, it's easier to fill the hopper manually. Looking at the 3D printing system, a gantry 3D printer consists of a rigid frame that moves the printer head in a three-dimensional space. Stepper or servo motor along with lead screw or belts are typically used for driving the printer head. This printer uses lead screw for all X, Y, and Z axes. Some printers, like this one, have more than one motor and lead screw for each axis to provide enough driving force. In this case, it is important to ensure both motors rotate at the same speed. Also, calibration or leveling is required in case of missed steps in the stepper motor. Now let's look at the extruder. A good extruder is a key for successful 3D printing. Even though both Auger and ram extruders have been developed and studied, Auger extruders are more common for continuous printing. This printer uses an Auger extruder. An Auger extruder typically consists of a hopper and a pump inlet. An auger is inserted inside the extruder barrel to push the material through the nozzle. Various types of nozzles with different shapes and size could be used depending on the application. The nozzle is removed at the moment and it will be added before printing based on the application. The printer is controlled by a central command system that controls the extrusion rate and the movement of the printer in a 3D space. It may also act as a data acquisition system to collect printing data like extrusion pressure, torque, or rotation speed, or other extrusion parameters, if there is any. This printer doesn't have any sensor in the auger, but I will show you another printer, which has a sensor that measures the applied torque. Here is a bigger 3D printer with different design, but there are many similar components. This is the printing system controller. Similar to the previous printer, this one also has two stepper motors for driving the printer head in the Y and Z directions. Here is a desktop printer with smaller design but more portable and easier to use for more accurate and precise prints. It can be used for printing concrete samples up to 3 feet by 3 feet by 1 feet or 900 by 900 by 300 millimeters. One important feature of this 3D printer is the extrusion sensor that measures the extrusion torque during the print process and allows for adjusting the extrusion rate if it's required. In summary, all of these 3D printing systems do the same task, but at different scales, similar to different mixers that we see here. While this full-size batching plant is very powerful and is useful in large projects, it's an overkill for small applications. The same is true for 3D printing systems. That's why we have multiple different mixers and 3D printing systems in the lab.